Okay, so I want to do some long division, and I want to do this. So it says use long division to divide. Okay, so I want to put this up under my division, and I want to start with my polynomial over here, and I want to make sure that I count down all the way for my placeholders. I'll show you what it gets. If I don't put placeholders in here, then things get really skewed and it gets messed up to keep track. Okay, so I want to just make sure when I'm writing this down, I'm going to write the top polynomial underneath my division, 3x fourth. I'm missing a square. This next should be a 3 third power, but I don't see it. So I'm going to put 0x cubed. I don't see a squared. And then minus plus 12x minus 33. 5, 4, 3, 2, 1, 0. These are going to be placeholders. Okay. And then my divisor, I put it out of here. Okay. And then I start. Okay. To do the long division, again, I want to focus on this and the leading term here. I want to turn whatever I multiplied by, I want to start multiplying this times this, and the only thing I'm focused on is getting rid of x to the fifth. Okay. What times x is x to the fifth? And if I'm not for sure, I'm just going over here and I'm saying, let me do this division. Okay, that would be x to the fourth. Is that it? Well, if I multiply 1x to the fourth times x, yep, that gives me x to the fifth. And again, that process will be quicker and quicker once you start practicing. X to the fourth times x, that gives me x to the fifth. And when I do a subtraction, this is going to be 0. And that's what I want. Every time, this thing is going to be just loads of zeros until I finish up. Okay? Once I do that, then I just finish multiplying out and do whatever it says. Okay? So the x to the fourth times negative 3 is negative 3x to the fourth. And then I just subtract this from the original. Okay, so this is a negative, that's going to be a plus. Okay, so x minus x to the fifth, that's going to be a 0. This always, when our first step, when we start running this thing through, is to get rid of the leading terms, and it's just going to be zeros. Okay, and then finish it out. So finish this out. This is plus minus 3x to the fourth plus because of the negative and a negative. In this case, it turns out to 0. This, you just do whatever it does, okay? But now this was just kind of going through, finish this up, and then bring that down. So the 0x to the cube, 0x squared. In this case, I'm just left with 12x minus 35, okay? So now I still do the very same thing. I want to multiply something times x to give me 12x. And I kind of line them up over here to whatever this value is. So this was, I need to multiply times 12. So this needs to be right above that number. Plus 12, because I need plus 12x here. 12x. 12 times negative 3 is minus 36. And then I want to do the subtract. This will be a negative, and then that'll be a positive. So 0 plus 1. So the result of that is x plus 12 plus 1 over x minus 3. So just like if I divided 7 by 2, I get, so if I went over here, here's my 7, divide by 2, 3 times 2 was 6, subtracted, I get a 1. Here's my remainder, but this result is 3 plus 1/2. This I couldn't do once I got down smaller, okay? When I do this process, I continue to where the degree of the remainder, this is the remainder stuff, is less than the degree of the divisor. This is my divisor. This is degree 0. This one is degree 1. I stop. I can't, it's just like this. Okay, I'm less than the divisor, so I stop, and that's my answer. And we just shorten this up to 3.5. We understand what that is. Okay, we're just used to not carrying this around. But when we do math with this, we're kind of thinking that it's that. So this can be any number down here as a divisor. Later on, we're going to see a very simple method called synthetic division, that if this is just a single, if it's a linear factor, degree 1, I can do this easy process. But when I've got powers greater than 1, then this is my only choice, is this long division. And again, I want to be able to simplify this sometimes into some form where I've got some polynomial plus some little, like 2 over, like 2x plus 3, x squared minus 3x plus 4. I want this to be a less degree than this, and what's going to happen is that over, as x gets large, this thing is going to go smaller and smaller because I'm dividing by x squared into an x. So this is going to go to some number 0, and then we're just left with this for the end behavior. Okay? So there's other reasons doing this just to do this division process. Okay. So I want to do this long division to divide this. So I want to divide 2x cubed plus 2x squared minus 16 plus 32 divided by the divisor x squared minus 3x plus 4. And again, I want this to go down as well, 2, 1, 0, 3, 2, 1, 0. If I was missing a term, I want a 0, because again, I want everything to kind of line up. Okay. So step 1, I want to multiply times x squared to give me 2x cubed. What do I multiply this to give me that? This needs to be the same each time so that when I subtract, it goes to 0, and I continue to do this out. Okay. So x squared looks like 2x cubed divided by x squared. That would be 2x. Okay, so that's what I need. So I'm going to go over here, right above that same power, I'm going to write my 2x. And then I start 2x times x squared, 2x cubed. 2x times minus 3x is minus 6x squared. 2 times negative 3 is negative 6. X times x is my x squared. Plus 4, 2x times 4 is plus 8x. Okay? So once I did this, I continue multiplying until I finish out, no matter how long I need to go. Okay? And then I just subtract all of this. 2x cubed minus 2x cubed, that's going to be 0. And if you need some help, go ahead and kind of flip these signs. And so this is understood plus, and then cross these out, because you've already done it. That's 0. 2x squared plus 6x squared, that's 8x squared. And then 16 minus 8x is minus 24x. And then whatever's left over, I bring down. and I basically start this process over again. Okay? So I want to turn x squared into 8x squared. 8 times x squared to give me 8x squared. If I don't remember, if I can't think this thing through, just take this divided by x squared, that gives you the 8. 8x squared divided by x squared gives you the 8. Okay? So 8 times x squared, 8x squared, minus 3x minus 24x, 4/8 plus 32, and then I'm going to subtract all of that, change the sign and add. This will be a negative, positive, negative. That goes to 0. That's 0. That's 0. This is the remainder. Degree of this is 1. If this had to come out with like an x plus 1, once I see the degree of this is less than this, there's nothing that I can multiply here to get me that, then I would stop. Okay? So the result of this is just 2x plus 8. If I graph this as a function and graph this, I'm going to be mainly the same graph, okay? The same graph here, except I have to worry about if there's any zeros that I've divided out, okay? And then I just have to pull those out of the domain. I would say is that equal to 0? Yes, it looks like no. So I can't factor this, but those, well, I have to do the quadratic formula and remove from domain. Okay. I needed 2 factors this, I've added to 3, and I don't have those. But I can do the quadratic formula, find the zeros, remove them from the domain, and this would be the very same thing when I graphed. This would be the very same expression either way. Okay, so those are some skills. We'll work on those in lab. We'll work on some more. And then I want to focus on doing long division. So how do we do to check what we've got is I start out with this, and then my result here, no matter what, even if I have the remainder, then I multiply this times this to give me, this, which is that thing right there. This times my divisor should give me this originally. Okay, just like if I had, in this case, I had 2 divided by, 6 divided by 2 was 3. How do I check? Because 6 is equal to 3 times 2. Okay, so if I multiply this times this, I should get my original. And that's what I'm going to do. So I'm going to erase my work. I have no remainder that I need to put in here, but I'm going to multiply this times that. So 2x plus 8. X squared minus 3x plus 4, and then I do distribute, and group them up. So 2x times x squared, I'm going to start over here, 2x cubed, that times that. Minus 3x, so 2x minus 3x is minus 6x squared, minus 6, and then the x times the x, and then the 2x times the 4 is my 8x. Once I distribute, then I start with here, plus 8x squared. 8 times minus 3 is my minus 24x, and then plus 32. And then let's group everything. 2x cubed, that's that out, minus 6x squared plus 8x squared, plus 2x squared, that gets that and that. I've got those two. That matches up. If it didn't match up, then I'd need to start working on what y, okay? And that 8x minus 24x, that's the minus 16x. Minus 16. Okay, so that piece is right. And then that's my only constant, and that's the 32. And this should be equal. And they are. So that's how we would check at the very end to make sure. In fact, this process is going to come up in just a little while with this remainder. It's called the remainder theorem. And we'll come back and visit this to start in just a little while. Okay, so synthetic division, if it's just a simple division by a linear factor in this form, x minus 8, okay? If it's in this form, then I can do this division in a simpler way, and the simpler way is called synthetic division, okay? So remember x minus c, when I'm dividing by x minus c, okay? So here's the example. I want to divide this. Now here's the way we're going to do this. I'm going to invert that division symbol. Okay, I'm going to invert it. I'm going to write what we're doing, and I'm only going to write the coefficients. So this is called the coefficient line. Coefficient line is the top. So I'm going to write this out. So I've got an x cubed. That means 1x cubed. Minus 13 is my minus 13x squared. 46, that's my plus 46x. If I'm missing anything, I've got to make sure I got a 0 in here for these. Okay, and then minus 49. Okay. So this is synthetic division by x minus 8. Okay. X minus c. This I put here is the positive version, okay? Just like the vertex. Remember I did the vertex as whatever that is. I moved it to the right. Think of that as the very same thing. Now here's the process. Now we start. We've got our coefficients. Here's the divisor. I only need this piece of it. The first thing I'm going to do is drop this down. Whatever this number is, that starts my process. That's a 1. Now I multiply. Whatever this is, I'm going to multiply through. 8 times 1 is 8, and I write it here. Plus 8, I keep up with my signs, and then I add. Minus 13 plus 8, minus 5. And then I do the very same thing. Multiply that times that and write it right there. 8 times negative 5 is minus 40. And then I add. Don't change the sign. Don't do anything. Everything is set up for just adding. 8 sixths is 48. So this times this. So right here is 48. And now this is my remainder. And this gets me the result. And what I do is reduce degree by 1. So if I started out with a 3rd degree, this was a 3rd degree poly, I'm going to reduce to a 2nd degree. And these are the coefficients. X squared minus 5x plus 6. And if I'm doing the division, this is minus, I'm going to use that minus out front, 1 over x minus 8, or plus negative 1 over x minus 8. We try to reduce the number of signs between these two. And that is synthetic division. If I did long division, it's going to do the very same thing. I'd have 3 or 4 steps. But in this case, that's going to be my result in either case. Okay. So here's the steps that you're going to do. Write the value in C in a box. Write the coefficients of the dividend to the right. So this is a couple of different ways that they're going to do this stuff. Skip a line, draw a horizontal line below the list of coefficients. So there's two lines. I just like to do this, depending on the book, but here is the way that I've always done it. And it just does the very same thing with the long division, except I'm kind of flipping the box. And then bring down the leading coefficient. That's that step. Write it below the line. Multiply that value by C, x minus C. Write it up to the next below the line. Write the result in the next column above the line. Add them. Continue until you've all the way got all of these finished. And that's my result. The rightmost number below the line is the remainder. That's the rightmost. This is the remainder. The other numbers below the line are the coefficients of the quotient, the result of the dividend divided by the divisor. That's the quotient. Here's the quotient. Okay. The degree of the quotient is 1 less than the degree of the dividend. That's where you reduce the dividend. This was an x cubed. I start with x squared. So let's do this again. Let's do it with this. So I've got x to the 5th minus 3x to the 4th plus 12x minus 33. And I want to divide this. I'm going to do this in a little different. That's in terms of like we expected in a rational. That is the very same thing as this divided by that, okay? So if I see this, I can simplify, okay? I'm only doing it with, this is in the form of x minus c. So that should tell you that you want to do synthetic division, okay? So I'm going to do the 3 directly, 3. And all I need is a little space for this. I need to bring down all of these things. Here's my x to the 5th coefficient 1, 5, 4 is my degrees. Whoop, I'm missing a cubed and a squared. 1 minus 3. The coefficient of the x cubed is 0. The coefficient of the x squared is 0. And then 12 negative 33. Okay? And then I'm ready to go. Okay, I bring down the first, add it to 0 if you will, 1, and then I start 3 times 1. So I need to do this times that and then bring it back up to here. 3 times 1 is 3, and then add, and then repeat. This is 0, this makes this easy. 3 times 0 is 0, add, 0, add, 0, 12 when I add now, and then 3 times 12 is 36, minus 33 plus 36, this is plus 3. This is my remainder, okay? And this, I use this bottom row, this was a 5th degree. The result is going to be a 4th degree because I'm dividing it by just that 1. Okay? So 4th degree, x to the 4th. 1x to the 4th, and I don't write the 1. Plus 0x cubed, plus 0x squared, plus 0x. All the zeros I don't ever write. Plus 12. And if I'm completing this out, this is 3 over x minus 3. X to the 4th plus 12 plus 3 over x minus 3. And now if I did this out, this should give me the very same thing that I started with. Okay. Let's continue. Let me do one more. And then we're going to get to some good results. Okay, so divide 3x cubed minus 48x plus 25x squared plus 20, and then divide that. This is the form that we're usually going to see that in, x plus 10. Okay. So here, this is not in the form of x minus c. But what I'm going to do is put this into this form. This kind of helps me keep up with it. This is what I'm going to write out in front. Okay. I need my c down here. Okay. That's my negative 10. And now my 3x cubed. I need this to be in correct order. So this needs to be 25 minus 48 and then 20. 3, 2, 1, 0. That needs to be in that order. It needs to be in countdown. So here's 3. And then this times this and bring it up. Negative 10 times 3 is negative 30. 25 minus 30 gives me my negative 5. Negative 10 times negative 5 is plus 40. This gives me 2. And then negative 10 times 2 is negative 20. And look at here. When I leave this, that gives me a remainder of 0. Here's my result. Started with a cubed 3x squared minus 5x plus 2. There's no remainder. This thing divided evenly in there. So this was like the form of this. Okay? If I have a remainder, that's what I get when I have a remainder. Okay? This is what I get. This thing totally divides out to this. Okay. When this happens, when r is equal to 0, it says evenly divides. Evenly divides. That's what that means. This evenly divides into that. In other words, x plus 10 is a factor. I could have wrote this as some other polynomial times x plus 10 divided by x plus 10. And what is that? That p of x is 3x squared minus 5x plus 2. We're going to use that later on. That's going to be part of kind of some results and everything that we're going to be working on. So let's look at the remainder and the factor theorems. Let me kind of get going here. So I've got some polynomial, and the remainder of the factor theorem is basically looking at dividing by some linear factor. Okay, the simplest method that we're looking at. Okay, so here it is. If this thing is a 0, if some number is a 0, then x minus c is a factor of f of x. Okay? And if x minus c is a factor, then f of c is equal to 0. So let me show you this. So if I did x squared minus 1, let me show you this through. This I can factor, right? X minus 1, x plus 1. Okay? I want to look, what about if I divide? I want to do the very simple, the x minus c version, x minus 1. If I divide that by x minus 1, I recognize, oh, I can do this by synthetic division, or I can do it long division, doesn't matter. But if I do synthetic division, there's my c directly. It needs to be divided by x minus c, okay? So the C goes here, which is just the 1. And now my coefficients would be 1, 0, and negative 1. 1x squared plus 0x minus 1. So I want to do synthetic division here, and let's kind of notice some things. Bring this down to a 1, and then I multiply. 1 times 1 is 1. I add, I get a 1. 1 times 1 is a 1, and I add, and I get a 0. My remainder is equal to 0. The result from this thing, take the original degree, reduce it by 1. So this is x plus 1. That's the result of doing that division. And if I'd have noticed that I could factor this and divide this, the x minus 1. This is the x plus 1. I would get the x plus 1. Okay. Now I want to do something else. I want to rewrite. Okay. So if I have x squared minus 1 over x minus 1, I divided that, and I got a result of x plus 1. You remember when I had 6 divided by 2 is equal to 3, and if I multiplied both sides, this is what I get? Well, my check is the very same thing, x squared minus 1, x plus 1. If I multiply both sides, if I multiply these together, that's what I get. Okay? Now, I want to look at this as a function. I divided by x minus 1. I got a remainder of 0. And now if I do that f of 1, notice that is my 1 plus 1. This is my factored form times 1 minus 1. This is 0. This will be 0. That's basically what this is saying as a remainder theorem. If I can divide a function by a factor, a linear factor, in this form, if I divide it evenly so that I have no remainder, then basically that is a factor. And then when I evaluate this function, since I can rewrite this, I have no remainder out here, then that is just going to be 0. When I evaluate the function at that, that's the c minus the c, this is going to be 0. If I have a remainder, if I had some remainder over here, then when I evaluate this, this would be the remainder. In this case, it's just 0, right? But let's say if I do x squared minus 1 by x minus 2. I want to do something a little different. So I want to divide by x minus 2. I can still do synthetic division. This is x minus 2. Okay. 2. There's my c. 1, 0, negative 1. 1, 2, 2, 4, 3. Now I've got a remainder of 3. Also, the factor theorem and the remainder theorem, I want to see this in just a minute, that if I did this process, so the result, x plus 2 plus 3 over x minus 2. Okay? And now, if I multiply both sides by x minus 2, watch what happens when I have a remainder. X minus 2 over everything, distribute, distribute. This is like I'm clearing fractions. X plus 2, x minus 2, plus 3 because the x minus 2 turns out. Now, so my original x squared minus 1, I can rewrite as this, but watch what happens when I evaluate, when I evaluate at x equal to 2, this is 0. The result is just 3, okay? And if I went back up here, and if I evaluated this, my x squared minus 1 at f is at this 2, this would be 4 minus 1, which is 3, okay? But if this is 0, then x minus c is a factor, okay? So if I want to evaluate, there's two pieces of it. Use the remainder theorem to evaluate f of negative 1. Okay, so what they want you to do with the remainder theorem is do synthetic division by x plus 1. Okay, so I'll do this real quick. Here is my negative 1. That's what I'm doing here. Negative 1. 5, 0. This is 7th degree, 6th degree, minus 3. 4th degree, 3rd degree, 2nd degree, 0, and negative 1. Holy cow. So I've got this long thing, and I want to evaluate f of negative 1. Okay, so this is basically synthetic division by this, which is the x minus negative 1. Okay. 5, negative 5, plus 5, 2, negative 2, plus 2, 2, negative 2, 0, 0, 0, negative 1 if I did all of these right. So negative 5, negative 1 plus 5, switch it, 2, negative 2, plus 2, negative 2, 0, 0, negative 1 times 0 is 0, so negative 1. Okay, so f of negative 1 is whatever the remainder is, and in this case it's negative 1. Now, I want to do this. And just check this. Odd degree, this is just, so if this was a bigger number, this would be a little easier. Here is a odd degree, so this is going to be negative 5. This is a negative, so plus 3. Plus 2, because that's a squared, and then minus 1. And then if everything went well, negative 5, 5, that's 0. This is the only thing that's left, and that's negative 1. Okay. So this gives you the remainder theorem. It's easier to understand that if this is 0, this thing evenly divides in there, and if it evenly divides, that is a factor of it. Okay, this is the result after we've canceled out the factor, and this times whatever we get gets the original. Okay. So this is very similar. Here's one last thing. Let me go through this and then we'll call it a day. Show that this is a 0 of f. Okay, so what I want to do, if this is a 0, then x minus the square root is a factor. And if that's a factor, everything cancels out. So what I'm going to do is set up synthetic division, square root of 5. So this just shows that it can be done with irrational numbers as well. My coefficients, 1, negative 4, negative 520. Bring this down, square root of 5 minus 4 plus square root of 5. Multiply this. This gives you minus 4 square root of 5 plus 5. Minus, this goes out, minus 4 square root of 5. When I multiply this times this is just going to give me minus 4 times 5. And this is minus 20. This is 0. Remainder is equal to 0. X minus the square root of 5 is a factor, divides it in evenly, and then f of square root of 5 is equal to 0, which that means this is a 0. Which kind of gets us to a good stopping point. Okay.